So we're going to talk about writing equations from a table or from a couple of points. So imagine you had the points -54, 12, and -53, 19. You could take those points and put them in a table like this and go from the table. I kind of like that better. But if you're given points, the Delta Math will just give you the points. That's fine. There's not an issue there. Take those numbers, kind of make a little table, go to town. Okay? So, how do I write an equation for a line that goes through those points? Well, there's a template that we've been using, and you've seen it before. It looks like this. Okay? Where we've seen this the most is when you have like the first number is 20, and the common difference is 12. Okay? We've done that a lot. 12 times, now a lot of times we'd write n minus 1 instead of x minus 1, but now that we're transitioning from patterns into functions, we like to use x instead of n. But it just kind of means that the first number is 20, is what we're going for. And the zero and the start, the slope is 12, okay, or the common difference. Well, the problem is, if you look at this table, I am nowhere near the first number. I'm at the -54th number. But the good news is that's an easy fix. These two numbers here and here can be any number from the table as long as they're side by side. So I could delete those two numbers, and I'm going to delete my slope and fix that in a second. But I could choose the numbers 54, -54, and 12. Or I could use the numbers -53 and 19. Or I could use the numbers x minus -52 and 26. As long as the numbers are side by side and they match up in the table or in a point, okay? For example, they may give you the point -52, 26. That's the same thing as being side by side in the table. All of those equations are correct. Now, I would clean them up a little bit, but let me finish the slope part and then we'll get to there. So as long as the numbers are side by side in a table, and I've mentioned that before, not very thoroughly, I haven't talked a lot about it, but it is true. As long as those numbers are side by side, they will work in an equation. Last thing I got to find is my slope. From 12 to 19, it went up by 7. Okay? Now we got to check one more thing. How did that change? Well, that one changed by 1. Okay? As long as this changes by 1, that's going to be your slope. 7, 7, 7, and 7. Because all of these have the same slope. So 7 for all of them. Okay? Now, I would take this and, for example, use the last one. Y equals 7 times. Now, when you subtract a negative, that's addition. If you have a hole in your backyard 51 feet deep and you want to fill it in, you have to add 51 feet of dirt. So that becomes plus 51. Oops, I forgot the 1. Okay, that's a good looking equation. If you look at the Delta Math, they try to write theirs in a different format. If you do it like this, it will count it correct. You don't have to adjust it or change it or use the Delta Math format. This is much faster and easier, and we're going to go with that for now. And it will count it correct as long as your numbers are right. Now, this template that I showed you, y equals something times x minus something plus something, that is called point slope. And it's called that because all you need is a slope and a point, x1 y1. The x goes with the x, so the first x value is there. And the y goes on the outside, y1. This is our point slope form. As long as you have slope and you have a point, and that point can come from a table. Again, my points all came from the table right there. Remember, even though it looks different, that is still a point. Okay? So, if you had this problem on a delta math, any of these four equations would be correct. Correct, 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 and correct. Let's try another one or two right here. Okay? Now again, my template is y equals slope times x minus the first x value plus the first y value. So let me find my slope from 43 to 34. Now, I'm going to be careful here because sometimes these numbers go up by 2s or 3s or 4s. So I'm going to find my slope using my rate of change formula. Okay, this is going to be x1 and x2, y1 and y2. And the way we find our rate of change, which again, slope is another way of saying rate of change, is we subtract the y's, y2 minus y1. We subtract the x's, x2 minus x1. That gives me 34 minus 43 and 22 minus 21. 34 minus 43 is negative 9. It's okay to have negative numbers. It just means that as you go down, the numbers get smaller. Then 22 minus 21 is 1, and we divide those. That gives me my rate of change, which is my slope. My slope in this case is negative 9. So here I put negative 9. Now, this is an x1, this is a y1. And I know I wrote x1 and y1 here, and that does work. But you can technically call any of these points x1, y1. So yes, you could put down 21 and 43. That is perfectly correct. Or you could put down the next point, 22 and 34. That is also correct. Or you could put down 23 and 25. That is also correct, because that's the point right there. Any of those pairs of numbers will work, okay? And the delta math, they show you equations that look more like this. They say, here are 2 points. And they'll say, write an equation. Well, I'm going to make that little table. 5, 7, and 7, 17. There's my x's, there's my y's. And I'm going to find my rate of change, which is, again, slope. I'm going to say x1 and x2, y1 and y2. Subtract the y's. Subtract the x's. And divide. That gives me 5. Then I use my template. Y equals slope times x minus x1 plus y1. My slope was 5. x1 is 5. y1 is 7. There's my equation. If you wanted to, you could write y equals 5 times x minus 7 plus 17. Again, as long as these two numbers match up in the table, it's going to be correct. So this is what the delta math looks like. But it's the same thing as using a table. They just write the points kind of separate in a table.